Okay, so I feel like I just completely butchered the tank problem, so I just want to go over it again. Um, Hopefully, if you watched the last section and you kind of got a flavor for it. And anyways, what we're trying to do is show that the change in the amount of salt in the tank, uh, the rate of change of salt in the tank is equal to the difference between the rate in minus the rate out. So again, the picture that we have is is some fluid coming into a tank, okay? And then there's another pipe with stuff coming out of it. The rate in we kind of know, right? Because they're giving you that this Q of 1 and R of 1. So Q sub 1 is the amount of salt per gallon coming into the tank. Okay, so its units will be in pounds per gallon. This rate is the amount of gallons coming in of the salt water per minute. So its rate will be gallons per minute. Okay, so this information is given to you. In other words, the rate in is not a mystery. The rate in is just going to be the product of these two. And you see if you go pounds per gallon, Q1 pounds per gallon, and then multiply it by R1 gallons per minute, you end up with Q1 R1 pounds per minute, which is the rate of salt coming into the tank, which is what we are concerned with. Okay, so pounds per minute. The trouble then is figuring out this outgoing part that we need for the difference here. So the rate out, we kind of don't know this Q thing here. We're kind of stuck and trying to figure out the amount of concentrate per gallon coming out because it's variable, or it might be variable. But they will tell you the rate of the solution coming up, that it's R2. In this case, the rate of solution leaving is R2. So R2 is the gallon per minute factor. Okay, so it's the rate of solution leaving, in other words, the salt water. And this factor here will be given in terms of gallons per minute, just like this factor up here. Okay, so there's this kind of a relationship between these two factors and these two factors with regards to units. Okay. The only trouble is we kind of don't know the amount of salt per gallon in this output. Right? So we need some, I guess, function that will give that to us. Okay? So what is that then? If we know the amount of salt at some given times t, we can figure that out. In order to figure this out, we're going to need to know the initial amount of salt, Q sub 0, and then we also need to know the initial amount of salt water in the vat. Okay. Okay, so this object here is what we're after. I know this thing is just R2. Okay, the rate of the solution leaving will be given as R2, and it's in gallons per minute. Okay, so this red thing is what I'm after. And what I'm saying is I can figure out a formula for it, which I'll call, well, I can write as Q of t, the amount of salt in the solution at a given time t, divided by V of t, where V of t is going to tell you the amount of salt water in the solution at any given time t. Okay, so this is the pounds of concentrate up here, LBS of concentrate. And then this element tells me the number of gallons of the salt water. Okay, so the units for this part of it should be in pounds per gallon. And then we're multiplying by this other thing, which is this rate R2, which is gallons per minute. So it's R2 times gallons per minute. And then you see, okay, the cancellation will happen, and I'll get the pounds per minute, which is what I'm after. Okay, so, right, I need an equation basically for V of t, the amount of salt water in the solution at any given time t. And what I was kind of going up in the video, you can kind of feel it out. The slope of that, the change, the rate of change of the gallons of salt water will be the difference between this and this. Okay? But you can also just literally go at it using points of given information. So V of t, we're going to say, is the number of gallons of salt water at time t that are in the tank. And at time 0, we have V sub 0 amount. And then at time 1, well, we have R1 gallons per minute coming in and R2 gallons per minute coming out. So when we are at 1 minute, the amount of stuff coming in will be, or the amount of additional salt water there will be R1 minus R2. Okay, so it would be V sub 0 plus this R1 minus R2 amount. Okay. Okay, so our formula for V of t will be V minus V1 equals M times T minus T1. That's our point slope formula. And all we need to do is figure out the slope, and then we'll use this point in this equation. Okay, so the slope from these 2 points is just this minus this. So I'll have V sub 0 minus V sub 0 plus R1 minus R2 all over 1 minus 0, which will be, of course, whoops, I screwed that up. I want to go this one first minus this one. Okay, so it'd be V sub 0 plus R1 minus R2 minus V sub 0 all over 1 minus 0. Okay, so that minus that. That, of course, then gives you this R1 minus R2 for your slope, which is kind of what I was going at. You know, after 1 minute, the amount of additional salt water will just be the difference between the amount that came in and the amount that went out during that 1 minute. Okay, so plugging this point and this slope into this formula, you're going to get V minus V sub 0 equals the slope, R1 minus R2, times T minus T sub, T minus 0. Okay. And then that'll just be V equals R1 minus R2 times T, plus V sub 0. Okay. So plugging that into this formula, this expression becomes the Q all over, what is it? V of t, which is R1 minus R2t plus V sub 0, and then times R2. So you would have an R2 up here as your factor. And then the differential equation is just going to be Q1 R1 minus that expression Q R2 all over R1 minus R2 times T plus V sub 0. Okay, so hopefully that was a little better of an explanation for this character. Okay, thanks for watching.